We're going to do S1 Jan 2011 question 6. It's worth 10 marks. So the question says we've got 7 cards, each with a number printed on them, and they form a 7-digit number. Part 1 says how many different 7-digit numbers can be formed using these cards. So first of all, what I decided to do was I've got 7 cards there, so it's going to be 7 factorial. However, we have got a few repetitions. We've got the 5s here repeating twice, and we've got the 3s repeating 3 times. So I did the 7 factorial, just because of 7 numbers, divided by the 3 factorial from the 3 repeating digits there, divided by 2 factorial because of the 2 repeating 5s, and I've got 420 there. So nice, easy 3 marks for that. For the second part of the question, if we go back up, it says diagram shows 5 white cards and 10 grey cards, each with a letter printed on it. From these cards, 3 white cards and 4 grey cards are selected at random without regard to order. And you'll notice that the word without is in bold, so that's quite important. It gives you a hint as to whether you use permutations or combinations. Part A says how many selections of the 7 cards are possible, and that is worth 3 marks. So what I decided to do here, well, if we want to figure out how many selections of 7 cards are possible, I said, well, we've got 5 white cards and I've got 10 grey cards. Out of the 5 white cards, I want to choose 3 which are white, and it said without order, so that means it's combinations. So that's going to be 5, choose 3. Then I need to pick from the 10 grey cards 4 of them, so that's going to be 10, choose 4, and because we want obviously 7 cards in total, well, 4 and 3 would give us a 7 there, so we're going to be multiplying these. So altogether there's 2,100 different 7-digit numbers we could have. Now part B says find the probability that the 7 cards include exactly 1 card showing the letter A. So what I did for this one here was, go to this diagram, I said, okay, in that case, we've got 2 A's. Let's take the first A. And so that's there, so that means from the remainder of the white cards that we've got, that's 4, choose 2 that I could possibly have. Now for the grey cards, well, we only want 1A, so I'm going to eliminate that grey one from my list. That leaves me 9 grey cards, and for me to choose 4 from them. So I eliminate the A, which is this one here because it's grey, because I only want 1A. And I'm going to multiply those 2 together, which gives me 756. I do the same thing, but I do it the other way round. So this time I eliminate the white A, and this time I say, okay, what if we've got the first card or a letter A being grey being chosen? So that meant from the white cards, therefore, again we eliminate that one, there's 4 white cards left, and I've got to choose 3 of them because I've already, from those selections there. Then I've got, from my grey cards, well, I've already picked 1 grey one, so that's 1 less. And that's going to be 9 grey cards, and from there, well, I've already got 1 grey, so that means I only need to choose 3 more grey cards, 9 choose 3 there. And again, I multiply them, and I get 336. Because the question asks me what's the probability of including exactly 1 card showing the letter A, I'm going to add these 2 up together. That gives me 1,092 out of 2,100, my answer from the previous part, and we can simplify that down to 0.52, and that is your 10 marks.